In this video, we'll be calculating the moment of inertia for a thin rod with the pivot at the center. So here you can see I've drawn a thin rod. The pivot is right down the center here. And I will be, again, considering a piece of the thin rod, which I'll call dm. It's a portion of the entire mass. And I'll be calling its distance from that pivot x and its length dx. So, reminder that the moment of inertia definition is the integral of r squared times dm over the entire mass of the object. And another reminder that if I do have this thin rod that I've divided up into tiny little pieces, this piece would have a certain mass and it would have a certain length, and the entire rod would have a certain mass m and a certain length l. And what I can do is I can set up a proportion. I can say that dm over dx equals m over l for the entire rod. That ratio should be the same. And I can rearrange this equation to write dm equals m over l times dx. So now what I'm going to do is I'm going to make a substitution for dm in my equation because I don't like having two different variables, r and m, in this moment of inertia equation. So I'm going to take the m over l times dx and I'm going to put that in for dm. And for r, if you'll recall, the radius or the distance of each piece from the center, I've actually decided to call that distance x. So this r is going to become an x. So I'm going to rewrite my equation with those two substitutions. When I do that, I'm going to have that I is equal to the integral of x squared, instead of r squared, times m over l times dx. And then I have to remember that I actually have two halves. So I put a 2 out as my constant, and then I'm going to integrate that from 0 to L over 2, because again, I'm going from the center out, and that's half the length of the entire stick. So now it's just integral calculus, so I can take my constants out of the equation, so I can write 2 times m over L, or 2m over L, and then the integral from 0 to L over 2, x squared dx. And this looks pretty doable. So I've got 2m over L, and the integral of x squared is 1/3 x cubed. And again, I'm going from 0 to L over 2. And my next step then is to substitute in my boundaries. So I've got that I is equal to 2m over L times 1/3, and instead of x, I'm putting in L over 2 cubed. So I'll just keep going. 2m over L times 1/3 times L cubed over 8. And that simplifies to ml squared over 12. And that is the moment of inertia for a thin rod with the pivot at the center.